I'm Kelly Knoll. I'm with Affiliated Engineers. I am on site at the Ann and Robert H. Lurie Children's Hospital here in downtown Chicago. It's an active construction site. We are building the world's tallest children's hospital. It's on a really small site as part of an urban environment, so it's less than 2 acres, 1.8 acres, over 24 floors. We have all of our mechanicals on 3 separate floors in the building. Just all of our building distribution is vertical because your building essentially is stood on end and stacked vertically rather than horizontally. So 3 major mechanical floors. We have our basement level where all of our generators are housed, and then our 10th floor, which has 52 air handling units, and then the 23rd floor, which has all of our cooling towers. Our 24th has cooling towers, and boilers and chillers are on our 23rd floor.
The more routine method of planning a building of this type is much more in a horizontal fashion, where you have building groups that are independent of one another and are served independent of one another with utilities that we design. So, for example, the clinics would be independent from the operating theaters, would be independent from the inpatient bed centers, would be independent of the administration function. In this project, they're all on top of one another. So how do we integrate the systems to make that happen? So the end result was primary utility plant at the top for mechanicals, primary utility plant at the bottom for electricals, and in the center is the air systems majority, we'll call it. 95% of all the air that's delivered to the building resides in its genesis in the center of the building. The challenge then was, how do we distribute and how do we make the verticality of that work? Shafts, commensurate with elevatoring, commensurate with the programs that want to exist on this postage stamp floor. The result was a slightly larger footprint at the top of the building than below it, which is where the major procedural floors are. Our structural partners tested a collection of different structural types. Is not one way to do it, and kind of paying attention to the fact that the building is a little bit broader, it's got broad shoulders, and it's a little bit taller and wider on top. They did use a rather substantial cantilever system that goes inconveniently through the mechanical room floor. One of the things that helped us with that was we delivered the project using a technology called building information modeling, and we used that to be able to digitally prototype the geometry of the building and make some sense over how structural engineering and MEP engineering cohabitate the same space, and know with a lot of confidence that it's going to work before you even break ground. Large-scale complex projects aren't unknown to AEI. They weren't unknown to this project. Projects, though, that had the unique challenges of Chicago-based urban verticality like this one does was a bit new, and we needed some creativity and thinking to make it happen. Urban and contemporary healthcare, I think we've learned that it's not impossible. And it's not impossible to do a fully functioning and flexible facility to meet contemporary needs for MEP and not be sacrificed by insurmountable inefficiencies.